Alright, this is the Chapter 3 practice test. You can download it from Canvas. And hopefully you guys can follow along, and hopefully this helps you with the test. So you may want to try it out first on your own and really practice it, and then come back to this video and just check your work. Alright, so starting with 1a here, we have negative 6 plus 4y equals 36. And what we want to know here is if this ordered pair is a solution to the equation. So if we look at A, we have 2, negative 12. So if we rewrite this, we've got negative 6x plus 4y equals 36. All we're going to do is we're going to replace the x with the x value in the ordered pair, 2. Then we'll replace the y as well with its y value, negative 12. Then we'll just see if this is a true statement. So negative 6 times 2 is negative 12. Plus 4 times negative 12 is negative 48. And as it turns out, this is negative 60. So this negative 60 does not equal this 36. This one, we would say, no, this is not a solution. Alright, 1b here is the same idea. I've rewritten the equation, negative 6x plus 4y equals 36. And from here, I'm going to go in, and I'll replace the x with the x value of the ordered pair, which in this case is negative 3. And the y value I'm going to replace with that 9/2. Okay, so now when I multiply these, negative 6 times negative 3 is a positive 18. And 4 times 9/2, well, looks like this is going to give us another 18, which does equal 36. So this one is a solution. Alright, number 2, first thing we're going to do is graph this equation. Then we'll determine if each is a function. Then we'll determine the domain and range, and then we'll write it in function notation. Alright, and it really doesn't matter what order you do these in, as long as you get the answer right, okay? But I am going to do this in the order that's laid out here. So first thing I'm going to do is go ahead and graph this. And hopefully that will help us determine if this is a function or not. Okay. So some of you may remember in class we talked about this. You can make a table for these values, and you'd have x and y. And what's going to happen is this is going to give us several ordered pairs to work with. And I'm just going to choose a few values of x. So negative 2, negative 1, 0, 1, and 2. And this should show us the graph pretty well. So I'm going to replace the x in the equation with the x value that we've chosen right here. Okay. Now I'm not going to be able to show my work here because I don't have enough space. But I probably will do it for one of them. Okay. So let's look at this first one. We've got the equation 2x cubed minus 1, and this equals y. Alright. So just like we did in number 1, we can rewrite this y equals 2, but now x is replaced. I'm going to start with that negative 2, and this is cubed minus 1. So following the order of operations, we get y equals 2 times, this would be a negative 8 minus 1. And then 2 times negative 8 is negative 16 minus 1. And we see that the y value is negative 17. You can use a calculator for this. I'm showing all the steps, but a calculator will take you from here directly to this negative 17. So we see this is negative 17. Okay, try those other 4 values. You may want to pause the video and then see how you do. Alright, the next value is -3. When x is 0, y is -1. When x is 1, y is 1. And when x is 2, looks like we get 15 here, okay? So now that I have a table with several values, I can graph this. And we're just going to make a few points. You can see the axis. This is my y-axis, and this is my x-axis right here. My first value, -2, -17, isn't going to fit on this graph. You would see maybe, if we bump this up, that -2, -17, maybe, it would probably even be farther down than that. -1, -3 is right here. I can make that just a little bit bigger for you guys so that you can see that. At 0 we get -1. When x is 1, y is 1 right here. And then we'd have 215, which would be way up here, okay? So now all I need to do is make a line, and we can see from these points that it's going to come up like this. It's going to curve just a little bit and then come up here. So looking at this graph, is this a function? Well, yes. How do we know that? Well, some of you may remember, and we talked about this in class, is the vertical line test reveals that this definitely is a function, okay? So we can make a few lines here to show. Alright, so you guys hopefully can see those blue lines. But you can see that they don't cross the line in two places, okay? Now, even though this line is becoming very steep as it goes to the right and to the left, okay, it's still moving towards the left and the right, okay, and that's going to help us with the domain. So yes, this is a function because it passes the vertical line test. The domain, once again, the domain are the x values, okay? So what x values are included here? Well, it would go infinitely to the left, so -infinity, and it would go infinitely to the right. The range, which is your y values, is the same because it will go infinitely down and it will go infinitely up. Last thing we have to do here is write this in function notation. So let's take a look at the original equation. Hopefully you can see that there at the top left. And we know we would have, instead of y, we're going to replace this with f of x as a function of x. Would have 2x, oh sorry about that, x cubed minus 1. And that's it. That's function notation for that, okay? Alright, now that we have those, at least A there, go and try B, C, and D, and we'll walk you through those. You may want to pause the video. Alright, so I'm going to do the same thing in this one as I did in the last one. I'm going to make a table, and this will give me hopefully several x and y values to work with as ordered pairs. And again, we can choose any values we want, but we want values that are going to be convenient. So these are pretty convenient values here. Alright. Let's go ahead and graph this then. So we have y. If x is -2, y, it looks like is going to be a fraction, actually 3/2. So this isn't going to help us out too much in terms of graphing. It's right in the middle of two lines, which is fine. But since we'd want some whole values, we can see that looks like we're going to want odd values here. So now that I know that, I can go down here to the bottom, and instead of 2 and even 0 like this, I'm going to use different values, okay? So I'm going to try a -3 and then a +3 in place of those. And the only reason I'm doing that is because I have a fraction. You don't have to. It's up to you. Just be careful with where you graph those halves, okay? Because some people get those mixed up. Alright, so if x is -1, then y here will be 2. And if we put these other values in for x, it looks like when x is -3, it looks like our answer is 1. Oops. 1. And when x is 1, looks like we get 3. And when x is 3, we get 4, okay? Alright, so now that we have that, let's go and graph these points. I'm not going to worry about that -2 and 3/2. But I will graph these other points. So I got -1 and 2, which is right here. -3 and 1 is right here. 1 and 3 there. And then 3 and 4. -2 and 1.5 would be about right there, okay? So next thing I need to do is just draw a line through these points. There we go. I'll put some arrows on the end of this thing. And yeah, we can extend it if we want, like this. And there we go. There's our line. Now notice this is straight. And that's because if you wanted to, you could have written this in slope-intercept form. This is kind of in standard form. But if you prefer to write it in slope-intercept form, that's fine. And then working with the equation from there. Alright, next thing we need to do is determine if this is a function. Is this a function? Yes, it is. Because it passes the vertical line test. We could draw several lines like this. And there's no curving anyways. So it's not going to come back and cross it twice. What's the domain? Well, we can see from the graph that it's going to continue to the left and the right. So those are our x values. It's going to go from -infinity to infinity. The range is going to continue to go up over here, and it will continue to go down for infinity, okay? And finally, just function notation. So we'll write it as f of x equals so I guess we will have to turn this into slope-intercept form anyways. So from the 4y minus 2x equals 10, we need the y on its own side, so we'll add 2x to both sides. And this gives us 4y equals, I'm going to rearrange this, 2x plus 10. Then we'll divide by 4 everywhere. And you'll see y equals, that would be 1/2 x plus 5/2. You may use decimals here if you'd like, but the fractions and improper fractions look much better. Alright, C. Let's go and take a closer look at C. Alright, so once again on C, we can make a table of this. And may need a few more values for this because it's an absolute value, but that's okay. Yeah, either way it's going to work. So let's try again the same values, -2, -1, 0, 1, and 2, and hopefully this will show us a pattern. Alright, now some of you may choose to start with the y-intercept, because if x is 0, we can see y is -5. Now if we move in the negative direction for x, so when x is -1, looks like we're going to get y is a -3. Now why is that -3? That's because that's an absolute value. 2 times -1 is -2, but this is the absolute value of that, which is 2, minus 5 is negative 3, which is what we got. And that was y. So when x is negative 2, it looks like y is going to be negative 1. Alright, well what if x is 1? Well, it looks like we're going to get the same thing here, negative 3, and then y here is negative 1. So from these ordered pairs, we are ready to graph. And the first one, again, if you want to choose to graph at the y-intercept first, that's fine. I've got a negative 1, negative 3, 1, 3. Then I've got 2, negative 1, and negative 2, negative 1. So from this we can make a line in these, like this, and like this, okay? Alright, is this a function? Well, yes, it's going to pass the vertical line test. And what's the domain? Well, the x value is going from left to right. Looks like it's going to extend in infinity, both negatively and positively. The range, however, has a minimum, and it includes this negative 5, but it will go for infinity upwards. Okay, so there's our range for this. And the function notation, since it is a function, we'll write it as a function of x equals the absolute value of 2x minus 5. Alright, now we have x equals the absolute value of y. So let's go ahead and take a look at that. We're going to find some values, but notice this one is written in terms of y. So even though our coordinate pairs will be x, y values, we need to choose values of y and then find the x. So we can do the same thing, use the same values like this. So when y is negative 2, x is a positive 2. When y is negative 1, x is positive 1. And these other values remain as well. So let's go ahead and graph these. And we can start with the origin. Here's our value. So when x is 1, it said that y is negative 1. And when x is 2, y is a negative 2. Likewise, when x is 1, we have y is a positive 1. And when x is 2, y is a positive 2 as well. And we could see that the pattern would continue in for both of these, rather. Okay, so let's go ahead and draw lines through these. That's going to be straight. Maybe that's not completely straight. Let's try it again. Alright, so it should come up like this. This one would come down like this. Is this a function? No, it is not. Because in the vertical line test, there's a vertical line and it intersects right here and right here. So we have two values, meaning when we put x in, we don't know what will come out. For example, even in the table we can see this. If I say x is 2, do I know what will come out for y? No. It could either be a negative 2 or a positive 2 here. So, when making the domain out, it starts at 0 as a minimum and will increase until infinity. The range on this is going to go from negative infinity to positive infinity. And function notation for this, well, it's not a function, so we don't have to worry about that. Otherwise, we'd have the absolute value of f of x, which it's not really common practice to write it that way, okay? Alright, and number 3, we need to determine the domain and range, and then if it's a function or not. Some of you may prefer to write this out as a mapping. That's completely up to you, alright? So the domain here, this is going to be a set of numbers. And it's all the x values. So we see that we have a negative 8, 12, 0, 10, and this is a negative 12. Okay, so all of those are listed. The range is all the y values, and we do need fancy brackets for this. Starts at 12, then negative 8, negative 14, negative 3, and then negative 8 repeats, but we have that listed already right here, so we don't have to list it again. So is this a function? So if I put any of these domain values in, or x values in, do I know what will come out? And the answer is yes. Now, even though negative 8 repeats for the range, okay, it repeats for different values of the x's, or the domain values. So, for example, if I put negative 12 in the domain, I know negative 8 will come out. Likewise, if I put a positive 12 in, I know a negative 8 will come out. So, that is okay. It makes it a function. So I know whatever I put in for x, I know what will come out for y. Alright, so this function, it wants us to find f of negative 5 on number 4. So rewriting this, I'd have f of negative 5 equals negative 4, but I'm replacing x now with this negative 5. That's squared minus 3, and again I replace x with negative 5 plus the 7. Alright, so I still have f of negative 5. This equals, first I have to do that negative 5 squared, which is 25. And I can subtract this from 3 times negative 5, negative 15, plus 7, okay. Now that negative 15 means we're going to do the opposite of subtraction, so I'm just going to make that a big plus sign. And right here we can see negative 4 times 25 is negative 100. And then I've got 15 plus 7, which would give us 22. So as it turns out, it looks like f of negative 5 equals a negative 78. Alright, number 5, write an equation of a line that passes through the following points. And we'll write this in slope-intercept form. And just as a quick reminder, slope-intercept, y equals mx plus b. M is the slope, b is the y-intercept. Alright, knowing that much, this is going to help. So now that we have these, and we're going to learn this in class, the change in y over the change in x, and that's going to give me a fraction. So I always start from the point on the left and go to the point on the right. From negative 7 to 3, that's going to increase the y's by 10. So that's a plus 10. From negative 5 to negative 5 is a plus 0. And 10 divided by 0 is undefined. Okay, so we can see the value of x is not changing, it's just negative 5. Now some of you may prefer to graph these, and if you did, you'd get something like this, which would give you a straight line through both of these, okay? So we can see very quickly on the graph that everywhere on this line, x is negative 5. Doesn't matter what the y value is, x is always negative 5. And that's the equation. Alright, on B we're going to do the same thing. So, first thing I'm going to want to do is find my slope. And to do this, I'll connect the y's on top, the x's on bottom. And I can see to go from negative 4 to 6, that's another increase of 10. And from negative 4 to 1 is an increase of 5. So my slope here is 5, that's positive. The next thing I need to do is figure out my y-intercept. There's a couple ways that we can do this. One of the ways is to write this, use point-slope form, because we have 2 points in slope. Or you could use this formula for finding the y-intercept. B equals the y value minus the slope times the x value. So if we replace these, we get B equals, we just need to choose one of these points. I'm going to choose 1, 6 because they're both positive. Not that that really makes a difference, but my y value is 6. My slope is 5, and my x here is 1. So that tells me that my y-intercept here, 6 minus 5 times 1 is 1. So as a point, it would be 0, 1. Not that that matters when we're writing the equation. We have y equals, the slope is 5, times x plus our y-intercept, which is 1. And there we go. Alright, next I'm going to do this using point-slope form. And you get to choose which way is better for you, which way you like the most. In fact, you could graph this and find that the y-intercept is 0, 1. The choice is yours. Alright, well in point-slope form we still need the slope on this, okay? So I'm going to go through this. Some of you may remember that point-slope form is y equals the slope, and then in parentheses you have x minus the x value plus the y value. Okay? And if we simplify this, eventually we will have slope-intercept form. So we have y equals the slope, which is 5. Then we have x. We'll have a minus and a plus there. The x value, again, I'm going to choose the same point, 1 and 6. You can use -4, -4. You're still going to end up with the same equation. And from here, what we need to do is distribute the 5. So we'd have 5x minus 5, and that's still plus 6. So we have y equals 5x, -5 plus 6 is going to be a positive 1. And you remember, that's the same thing that we just barely got. So you get to choose which way you like the best. Alright, on C we can see once again the x values are repeating. You can find the slope if you want. The slope is undefined, so since the x is repeating, just know that it's the axis, the y-axis, where x is 0. Now if these had been switched, it would just be y equals 0. So just be aware of that, okay? Alright, let's jump to D. So again, I'm going to find my slope on this. As a fraction from -6 to 0, this is going to increase by 6. From -3 to -6, this is going to decrease by 3. So I have 6 over -3, which tells me my slope is a -2. So just real quick, once again, this is a -2 because of the -3. This 3 is negative because it went from -3 to a smaller number, or lower number, -6. Alright, you get to choose the way you do it. I prefer to use this formula, the y-intercept, I guess I should put a B, equals the y minus the slope times the x value. It allows us to choose one of these two. One of them is 0 on this one. So I'm going to use -6, 0. So my y here is going to be 0. My x value is a -6. And we have a slope of -2. And that's my y-intercept. So I have 0 kind of goes away. So we have a 0 minus -2 times -6 is a positive 12. 0 minus 12 is -12. This allows me to write the equation y equals mx plus b. And I have a y and x. And my slope was a -2. My y-intercept is a -12. And that's my equation right there. Now, of course, you can use point slope form if you want, which we kind of did on B there, to find the y-intercept. Doing it that way will set up the equation so that you don't have to plug anything in, and you'll end up with slope-intercept form once you've simplified everything. But the choice is yours. You can find the slope and use that formula to find the y-intercept, or you may use point slope form. But you do have to find the slope in point slope form before you do anything, just like you would in slope-intercept form. Alright, 6. Find the slope and y-intercept of the line to y minus 12x equals 36. Pretty much all this is telling us to do is write this in slope-intercept form. So I need it to be in this form y equals mx plus b, which right now it's more like standard form. So I need to get the y on its own side of the equal sign, so I've got to add this 12x to both sides. And that would give me 2y equals 36 plus 12x. So all that's happened here is that my mx and b have switched places. I can change that. If you want, you can change it so that you have 12x plus 36. That's the commutative property of addition. And from here, we're just going to divide by 2 everywhere. And we end up with y equals 12 divided by 2 is 6x. 36 divided by 2 is 18. And that's the equation. So the last thing we have to do is figure out where is the slope. Well, it's right in front of the x. It's the coefficient of x. Slope is 6. You may write it as 6 over 1 if you want. Both of these will get you full credit. The y-intercept, as we can see, is right there where the b would be placed. The y-intercept, though, is a point on the graphs where the x value is 0, and we can see that it is 18. Alright, 7 and 8. We just have to determine if this is parallel, perpendicular, or neither. Alright, so the first one here, number 7. Let's take a look first at what we need to see if they're parallel. So if they're parallel, how do we know they're parallel? So your slopes are the same. So you'd have same slope. But also you'd have different y-intercepts. If they're neither, then you have different slopes. And for perpendicular, all you've got to do is look at the slopes. They'll be different, but they're very specifically different. They're going to be the opposite reciprocals. And hopefully you can look in your notes, you can look in the book about to figure out that stuff. It's possible that these examples will help us out as well. Alright, let's look at number 7. The first thing here is we know they are different, the slopes. I'm going to look at the slopes first. So the slopes on 7, they're different. The thing is, since they are different, are they opposites? Well, no. This 6 is positive, this 1/6 is positive. So even though they're reciprocals, This one is neither. Since the slopes are different, as it turns out the y-intercepts, this doesn't matter at all. All we know is that these are different. Alright, in number 8, let's look at the slopes first. It's the coefficient of x. They are the same. Slope is negative 15 for both of these. Now we have to look at the y-intercepts. These are different. So since the slopes are the same and the y-intercepts are different, these ones are parallel. Alright, number 9, write an equation that is perpendicular to f of x equals negative 5/7 x plus 18 and passes through this point. Alright, so we can use point-slope form. We'll know what the slope is just because of the equation though, okay? So let's look at this. Again, we want this to be perpendicular to this equation. So since it's perpendicular, it should be the opposite and the reciprocal. So this slope is negative 5/7. The opposite will be a positive, but we have to reciprocate 5 and 7. So we'll have a 7/5. And this is the new slope. This is the slope of the perpendicular line. The next thing we need to do is ensure that this point, that the line goes through this point, negative 5,1. So again, you can use point-slope form, or you can use the formula to find the y-intercept. But we can write this in slope-intercept form, and we could start that right now. Y equals a positive 7/5 x, and the last thing we'll have to do is figure out the y-intercept. So to do that, let's try point-slope form, because last time in number 8, I think it was, we used the formula for finding the y-intercept. So let's look at this, alright? So we got y equals the slope, which is 7/5, and we'll have x minus the x value of that point. Let's take a look. Negative 5,1. So the x value is negative 5, and the y value is a positive 1. Alright, to solve this, we'll have to distribute the 7/5, which leaves us with y equals 7/5 x. And we could have made that a plus if we wanted to. It's not going to make a difference in the end, because it's just going to be a positive 7, and that's plus 1, which really gives us y equals 7/5 x plus 8. So in our answer, we can go ahead and write this as a plus 8. Alright, in number 10, we want an equation that's parallel to f of x equals negative 6/11 x minus 6. Alright, so for a parallel line, we want the slope to be the same. So we know the slope will be the same, negative 6/11. But we notice as well that it's going to pass through this point, 44, negative 3. Alright, so in number 9 we used point slope in order to find the equation. In this case, since we have the slope, let's just go ahead and use the formula for y-intercept to solve for that. Then we'll just write slope-intercept form. So the y-intercept b equals the y value minus the slope times x. And the y value here we can see is negative 3. The slope, we have a negative 6/11. And the x value is 44. So using the order of operations, we've got this negative 3. There's nothing to multiply on there. And this is minus negative 6/11 times 44 is going to give us a negative 24. Well, since that's minus a negative, the opposite of minus is plus. and we end up with this y-intercept being 21. Now you can write the equation as an equation. You may write it as a function if you choose. They're linear. We know that because we can write in slope-intercept form. So let's go and write this as a function, just because if you want to, you can. F of x equals the slope, which is negative 6/11 times the x. And the y-intercept was a 21. So this is our answer right here. All right, for A, I'm going to go ahead and 11A. I'm going to go ahead and put this into slope-intercept form. I don't remember doing that in this yet, so let's go ahead and do that. And then we'll graph it from the slope-intercept form. So we need the y to be by itself. So what we're going to need to do is add 8x to both sides. Now since if we add and subtract, it's not going to affect the inequality there. So this becomes a 0. What we're left with is a 4y is greater than, I'm going to make that an 8x plus 12. The last thing I need to do is divide all of the terms by 4. So y is greater, and since we divided, we would want to check to make sure that we're not dividing or multiplying by a negative, which we're not, because if it does, it's going to flip that inequality. So 8x divided by 4 gives us a 2x. 12 divided by 4 is, 3. Alright, so from this we have a line. We know the y-intercept here is 0, 3. And we can make a point right there, right now, which we will do. 0, 3, right there. Now what I'm going to do is I'm going to use a slope, and I'm going to make that a 2/1. And from here I'll zoom in. Since it's 2/1, I would go up 2 to the right 1, which gives me my next point. And I'll do the same thing, and I will repeat this process. This will take me to the right, okay? So let's go ahead and finish that off. Up 2 to the right 1, up 2 to the right 1, and the next point will be off the graph. So we don't have to worry about that right now. But I have these points. Now we could look back at the slope. The slope is 2/1. That took us to the left. That took us to the right. If I wanted to make this take us to the left, I would just make both the 2 and the 1 negative. What that's going to do is when I go into this, you'll see that since we have negative values, I'm going to go down 2 and to the left 1, down 2 to the left 1, and I'll create this staircase, and you'll see that it makes the pattern consistent with the points on the right. Okay, so let's go ahead and make those points. Now the reason I'm making these points and not a line yet is because it's an inequality, so some of these actually may end up being dotted lines, okay? So there's all our points, and we can make a line on these. But the question is, what kind of line? Well, since it's an inequality, let's look back at the original equation, which you can see right here. Or we can look at this one. It's not going to make a difference. We can see that y is greater than this quantity, okay? So it's not equal to, meaning that the values on the line will not make this a true statement. So what we need to do is we'll graph this line. But since it's not equal, it's not a solid line, okay? So I've got some parts of this line. I'm just going to make it dotted, and it's going to go straight through those lines. Okay, so you can see some spaces in there if you want. Just make them bigger, whatever the case is. So go ahead and ignore the purple there. That's just the steps. That's how we use the slope to find out where the line is. Well, we got to figure out if we're going to shade on the right of the line or on the left. And to do that, we're just going to choose any point. And since we see that this line does not go through this point, the origin, that's going to be the easiest point to use. Now, if this point gives us a true statement, then we'll shade where the part of the graph that has that point. If it's false, then we'll shade the other half, or the other side of the line. So let's go ahead and look at the original equation, because we should use the original here. We had negative 8x plus 4y is greater than 12. Well, if I replace x and y with a 0, 8 times 0 is 0, and negative 8 times 0 is also. 4 times 0 is 0. And is 0 greater than 12? Because if we add these, we'd get 0. Well, this is an untrue inequality. And since 0, 0 is right here on the right side of the line, all that means is that we are going to shade in the left side of that line. So we'll go and do that like this. I'm not really looking for perfection on the test or at any other time. This tool kind of makes it a little bit easier to do this, but if you just wanted to use lines, that's fine. It's really up to you how you want to do it, but I do need to know that when you shaded in this side, that you meant to shade in this side, okay? The left side of this line. All right, let's go and look at B. So on B we have this equation. Let's go and give ourselves some space. All right, if we solve this, we're just going to divide by 2 on both sides. And what we end up with, and since those are positive, it's not going to switch the inequality, even though the 6 is negative, but we're dividing by a positive 2, so there's a negative 3x. If you want, you can put plus 0. That just may help you to figure out what the y-intercept is. So, moving along with this line, we can see that we're going to start here at the origin. And it's also important to remember that this is greater than or equal to, so the line will be a solid line. And let's go ahead and use the slope to figure out where these other points go, okay? So that's a negative 3 over a positive 1. So I'll go down 3 to the right 1 from the point, the y-intercept point. That will give us our new point, okay? So we know that this corner of our staircase is the next point. And we'll continue this pattern and create these next 2 points. Alright, now we see the slope. It's a negative 3 over positive 1. This is the same as a positive 3 over negative 1. And I can continue this pattern now to the left, which will help me create and finish this staircase. So I'm going to go up 3 now and to the left 1, giving me the new point. Up 3 to the left 1, up 3 to the left 1, and we have these points. So now that we have those, we can make our solid line. Again, it's solid because it's also equal to. Alright, so there's our line. Now we can't use the origin because it's on the line, and since it's equal to, we know it's a good point, but we need to figure out a different point to use. I prefer to use something with 0 in it, but you can choose whatever point you want. Alright, so let's go ahead and figure that out. So we have our original equation. We got a 2y is greater than or equal to negative 6x. And the point that I'm going to choose here is 1, 0. Okay, so I'm going to use this point, 1, 0. If I find that the inequality is correct, then I'll shade the side of the line that that 1, 0 is on. If it's not correct, I'll shade the other side, just like we did in the last one. So to solve this one, we have the 2 times the y, which is 0. Is this greater than or equal to negative 6 times the x value, which is 1. So 2 times 0 is 0. Is that greater than or equal to negative 6 times 1 is negative 6? Yes, this is a true statement. So I can see that on the line to the right, this point is on the right side, so I need to get all of that colored in here. So let's go ahead and color that in. And there's our answer, okay? Now the shading again the shading means that any point on this side of the line is going to give us a true statement. Okay? Anything on the other side of the line is going to give us a false statement. So there you go. There's the graph. Again, you don't need the dots there, but that was just to illustrate that all those points would work. All right, number 12, graph each union or intersection. Well, 12a, here we have these two equations, and the second one is already written in slope-intercept form, so we can start graphing that. We can see we'll have a y-intercept at negative 3, and the slope here is a negative 1/2. So if we got that negative 1/2, we'll apply the negative to the 1. So we'll say we got a negative 1 over a positive 2. Again, that will always make us go to the right because the change in x is positive. So I'm going to go down 1 and to the right 2. That gives me my next point. Down 1 to the right 2, and I'll continue this pattern till I get to the end of the graph, as you see there. And I can indicate that I'm graphing this line in red with just by circling that it's red. You don't have to do that, but it may help you understand. All right. Well, we got to take the opposite of this numerator and denominator, so we'll have a positive 1 over a negative 2. That will make us go to the left. So we can see we're going to go up 1 to the left 2, giving us a new point. Up 1 to the left 2, and we'll continue this pattern. Oops, there we go. And that gives us this line. All right. So again, that line is positive. It is solid because it's also equal to, okay, so y is not only less than, but it's also equal to negative 1x minus 3. So this one has an open value for me to try, and I am going to choose to try 0, 0, okay? So if it's a true statement, I'll shade above the line. If it's false, I'll shade below. So let's check. We have y less than or equal to negative 1/2 x minus 3. Of course, I'm going to replace y with 0 and x with 0, minus 3. All right, so we would end up with 0 is less than or equal to negative 3. This is false. And that's fine because it allows me now to shade below this line, okay? We know that below that line is going to give us true statements, okay? Now this other equation, which we can graph here, let's graph it in blue, got negative 2x is greater than y. So to graph this, we can see that it goes through the origin, and the slope is negative 2 over 1. So I'll go down 2 to the right 1, 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 and so forth. Okay, so that gives us our new points on the line. We can even see where those two lines intersect. And if I reverse that, then I'll go up 2 to the left 1, up 2 to the left, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And that allows me to graph these new points. Alright, and I can graph the line. So the final thing we need to do here is, there's a couple things still that we must do. And the first is to look at the original inequality. So we have this, it's just that it's greater than, okay? Now what this means is that we need to come back here and we just need to make this blue line so that it's dotted or dashed, whatever the case may be, whichever one you prefer. And now what I can do is go ahead and figure out which side of the line to graph on. Okay, so I'm going to choose the point 1, 0. And that allows me to come over here. If I take the point 1, 0 from the original equation, -2, x is 0, I'm sorry, x is 1. Is this greater than 0? Well, -2 times 1 is -2. -2 is greater than 0. This is not true. So we know on the right side of the line, this is going to give us false values. Which means, all this means is that we need to shade on the right side of the line, which is fine. So at the line we have the shading here. Now the actual solutions lie where it's shaded twice, okay? So you can see the yellow shading and you can see this pink shading, and they come together. Again, the reason we're looking for where they come together is because it said back in the original problem and. That's where the two intersect. And we can see the intersection very clearly is this area, which is green here. All of the solutions are in this area. Okay, so on this next part, it's the same idea. And I'm going to graph this line in red. Now I'm going to rewrite it as well. You've got y is less than or equal to -2x plus 4. So that gives us a line with a y-intercept of 4. And you can use the staircase method, whichever method you choose, to graph these next points and these next ones as well. Okay, this is going to allow me to make a line. And the next thing I'm going to do is just test out the point 0, 0. So the point 0, 0 is right here. And to test it out, I'm just going to replace y with 0. Is this less than or equal to -2 times 0 plus 4? This is going to end up being 0 is less than or equal to a positive 4, which is true. So this is going to allow me to shade in this area, the same side of the line that 0, 0 is on. And we'll start on this line. And notice again that that line is a solid line because it's also equal to, meaning any of the points on the line will give us a true statement. Next thing we need to do is graph this line, which I'm going to do in purple. So that's going to give me y is greater than 4x minus 2. So starting with our y-intercept at -2, I'm going to use the slope to figure out the rest of this line. Alright, so there's the points to the right and the points to the left. There we go. And now I can make a line just like this. Okay, now we can see this line doesn't go through 0, 0, so I can use it. In addition to that, we can also see that this line, the original equation is just that it's greater than. So I am going to have to make this a dashed line, dotted, whichever one you choose, as long as we know that those values are not solutions to this line. And I am going to try again using the point 0, 0, which is right here, to see if this makes it a true statement. So if we go back to the original equation, we've got negative 4 times 0 plus 0. Is this greater than negative 2? You'll end up with 0 is greater than negative 2. That's true. So if we wanted to shade in this area, I'm going to go ahead and use green. Okay, because 0, 0 is on the left side of this line. And there we go. Okay. Now in this problem, we're not looking for the intersection. We actually are looking for any part that's shaded. Okay. So we would have to acknowledge that the parts on that dotted line are not solutions, but parts on this line, this half of the red line, are. Okay, so anything in this area is going to work, anything in this third area, and even this fourth area will work, because it's the union, and the union means any part that's shaded. Okay, it's just combining. If it's a solution for one of the equations, then it is a solution for the whole system. All right, number 13. On this one, for each part, we're just solving for f of 3 or 0 or whatever it is. We're going to replace x with these values. So we have f of 3 equals negative 7 times the 3, because we're replacing x with 3, minus 8. And if we were to put that into a calculator or solve it, looks like we'd get a negative 29. So the way you should write this, to give full credit, is that f of 3 equals a negative 29. Now the reason we write this is because we want to show that it is a coordinate pair, and that allows us to do it for the rest of these as well. So f of 0 equals negative 7 times 0 minus 8, which is equal to negative 8. So I would write my answer, f of 0 equals negative 8. Same with C, except for now we have a little bit more than just one single value in there. We've got f of x minus 1 equals negative 7 times x minus 1 minus 8. Continuing this solution, we'll have to distribute the 7, negative 7x plus 7 minus 8 tells us that f of x minus 1 equals negative 7x minus 1. Finally, this final one, f of x plus h equals negative 7. Again, replacing x with x plus h, minus 8. Distributing the 7, negative 7x minus 7h minus 8. And that's it. We can't combine those terms. None of them are like terms. We have a f of x plus h equals negative 7x minus 7h minus 8. All right, well, I hope this has been helpful. If you need to watch it a few more times, that's fine. Remember, you can pause it anywhere you want. And good luck on the test, you guys. I hope this has been helpful.